Welcome to another session with Tutorac. In this particular live session, we are going to demystify one of the strongest confusions that most developers might actually have. So, whenever we talk about software engineering in general, we always talk about developing softwares that can make a large impact on a customer's life. Now, there can be so many softwares that can be developed like that. And there are too many tools that we are actually using around us as well. So if you are somebody who is living in India, of course, you might have heard about applications like Swiggy, Zomato, Blinkit, Zepto, etc., etc. These applications have really helped us improve our quality of lives over the period of time, right? But have you ever imagined that every single time when you sign up on these platforms, or every single time you actually place an order on these platforms, you are always allowed, or you always have a way to go back to your orders and see your order history. You can always see how much amount of money you paid, what was your payment method, what did you order, and how much you paid for every single specific item. What I'm trying to say is all of this information is actually data, and this data is actually made available to you. This data is actually consumed by these services as well, and they are also available to you so that you can use it for your own purposes. The main elephant in the room over here is actually the word data. Every single time, whatever application we use, there is a lot of data that is supposed to be kept and a lot of data that is supposed to be used. Even by large scale applications like Amazon to a very small scale, or to a very small scale application like maybe a regular shopkeeper's grocery shop, every single of these applications will be requiring one way or other through which they are able to store data. Data is actually one of the most important things that we have today in the information technologies world. It is also called as gold today. You might have heard a lot of companies selling data and doing data infringement and etc. etc. Why is that? Because data happens to be one of the most crucial elements in today's world. Today, in this particular video, we mostly want to cover the ideas towards data and how we can store it as a software developer. Whenever we talk about storing data, we will always come with words like databases. What is a database? What are the different types of databases? What is the benefit of each type of database? When should we choose of what database we should be using, and so on and on and on. So many queries that exist inside minds of so many people, whether they are about to start their career in IT, or whether they are a current aspirant, or whether they are already a working professional. So many things happen around the ideas of data. Let's go ahead and talk about databases. Right now, just a few moments ago, I did talk about that there are multiple types of databases. And before that, I actually want to clarify what is a database. In the most simplest manner, I can say that database is nothing but a software. Database is nothing but a software which actually helps you to store data. Now, there are so many ways or so many types of softwares that can store data. It can be very simple like a text file also, or it can be like a JSON file also, or it can be a very proper database also. So database is like a software that can store data. Usually, each of these softwares that are called as databases that actually store the data, they do follow a few certain set of principles and rules and regulations in order to maintain the data in a way that it is supposed to be expected. Data is very crucial. Therefore, these databases definitely necessarily need to support these important principles so that the data does not get lost or the data always stays consistent. This is the idea behind most databases that we have in today's world. You might have heard very popular databases names like MySQL, PostgreSQL, and Cassandra DB, MongoDB, Windows SQL, etc. etc. There are too many different types of databases that are available today in the market, and we want to categorize each of these major different databases. Let's try to talk about distinguishing these databases into two major categories. One of the major category about databases is something called as a relational database. It is also called as SQL database. And the other category is non-relational database, which is also called as NoSQL database. NoSQL here, NO of NoSQL stands for SQL or not only SQL database. That is what no means. No here means not only, and then SQL means SQL. Whereas SQL stands for standard query language. So here the word SQL is actually a language, and everything that we can do with the help of this language SQL is what is used inside databases. So let's talk about these two different types of databases that we have. So first type is relational database, which is also called as a SQL type database. So coming to my screen, I would like to help you understand what is a relational database with very simple examples. So right now I am going to open an application on my laptop called Numbers. So Numbers is very similar to an Excel sheet, as you can see already. So if you are somebody who has previously used something like Microsoft Excel or something like Google Sheets or any spreadsheet of your choice, you might be able to make sense out of this application that I currently have on my screen. So this application is called as Numbers, and in this particular application, I would like to help you understand what is a relational type database. Okay, so giving you a very top level view, let me just expand it a little bit so that it looks slightly bigger on your screen. So you can see that here are some certain rows and some certain columns, right? So technically, a relational database will also have a few rows and a few columns. Let's try to talk about this table as something called as employee table. Employee table. Okay, so I've written something called as employee table. Now, what is a table? A table is nothing but a combination of rows and columns where every row denotes a specific data unit. Okay, where every specific row refers to a specific data unit, and the column refers to the idea of what is the type of that data or what is the nature of that data. For example, let's say I write a few categories, let's say serial number, or let's say employee ID, EMPLOYE, employee ID, then I write name, and let's say then I write department. Okay, so these are the three things that I've written on my table, which are going to talk about the employee's information. Very much like when we were in school, we had our attendance register, right? Which did talk about how many days we were present, who are the students that are present in the class, and so on and on. So let's say we have this information. Let's say there's an employee whose employee ID is 1. The name of this employee is, let's say, Vinay, and the department is, let's say, direction. Okay. Let's say there's another employee whose employee ID is 2. His name is Nitish, and his department is branding. Okay. Then let's talk about a third person. Let's say this information, the name of the person is Charan, whose department is camera. Okay. So there are 3 employees present in my database, which are uniquely identifiable with the help of their employee ID. Okay, so this kind of data or this kind of way of storing the data is actually called as relational way of storing the data, or we can also say the SQL way of storing the data. Here, the employee ID is always specified to be, let's say, an integer, which means that the employee ID can never be something other than an integer. Suppose I can't write an employee ID, let's say hello. This will be an invalid entity in case of a relational database. Okay, so this is what I'm trying to specify over here. The code or the screen that you're seeing on my own laptop right now, it is a very top level example of what a relational database might look like. Also, when I say relational database, it means an SQL type database. So in this entire live video, every single time I say relational database or SQL database, they are used interchangeably. Similarly, every single time I use NoSQL database or a non-relational database, they are also going to be used interchangeably. So right now, coming back to my screen, you can see that there are 3 columns: employee ID, name, and department. So in this case, you can see that the name is actually a type string and department is actually a type string as well. So here, a very structured idea is defined that every single time a certain information is put inside the employee table, it has to follow a certain rules and regulation. For example, that this employee ID has to be an integer, the name has to be a string, and the department has to be a string again. Let's say I add one more employee. Let's say I write this, suppose I write my own name, Shantanu, and I write my department as IT. Okay, so there are 4 employees right now in this particular employee table. Tomorrow I decide, let's say tomorrow I'm deciding that I want one more column. Let's say tomorrow I decide I want one more column. And let's say the name of this column is, let's say city. The name of this column is city. Okay, and for this 4th entry that I've added, let's say I want to add a city, let's say Hyderabad. Okay, so I've added a city. Okay, so in this case, in a relational database, this will become a problem. This will start to become a problem because every single time when we are dealing with a database which is relational in nature, changing the schema becomes a problem. Now, I'm using a new word here called a schema. Schema is basically a definition of the type of information you want to store inside your database table. So every single database table is going to be associated with the idea of a schema. At the time of declaring your database or at the time of creating the database, you are bound to actually tell your database what is the schema you are requesting for. And that schema is very difficult to change or probably not even possible to change in multiple cases. So this has one advantage and one major disadvantage as well. The advantage is that the data in all cases is going to be structured and predictable. Whereas the disadvantage is that you can't really change it and you can't expect flexibility from this particular data. So the database which are of relational type, they actually do follow a very strict schema type. There is also another thing that I want to tell you about relational databases, and that is that they follow a property called as ACID, which is also very popularly called as acid properties. So ACID standing individually for A for atomicity, I for isolation, or C for consistency, and D for durability. So let's try to decipher each of them one by one. So atomicity means that every single transaction that happens, it will be either completed or it will be incompleted. It can't be stuck at a middle step. That is what it means. So every single transaction that starts, it has to complete whether it succeeds or fails. This is very important property of a database. For example, let's say you're trying to add a new field inside your database or a new row inside your database for, let's say, some newer information. According to this example, let's say you're trying to add a new employee to your system. At the time of adding this employee, you can't basically be stuck in a process which is somewhere in the middle of adding the employee and not adding the employee. You have to either add it or not add it. So the database internally needs to handle this kind of situation, which is how the atomicity property of databases come into picture. The second important property is called as consistency. That is, the database needs to be consistent before and after any transaction has happened. And the third, and in my opinion, one of the most important properties of any relational database would be called as isolation. So isolation basically means that, let's say that your database is receiving so many requests at the same time. Let's say you're trying to add multiple employees at the same time. So each of these requests need to be handled in isolation. That means they need to be in non-interference with any other information or any other request that is coming at the same time. This is very important to maintain the consistency of the database as well as the operation of the database. So isolation is also a very major property of all of the relational type databases. And lastly, coming to durability. Now, whenever we say, oh, you know what, this pen is very durable. Or do you know what, the tires that I put in my car or on my motorcycle are very durable. What does that mean? When we say durable, it means long lasting, right? We say long lasting. Now, whenever we want to say that a database is long lasting, it basically tries to imply that your data is long lasting. That means your data does not get lost over time. So every single time that any problem can happen to your database needs to be durable so that your database can come to a state when it was not inside a fault. So these are some very important properties that all the relational type databases have to follow. To name a few major examples of relational type databases, it would be MySQL, PostgreSQL, SQLite, and Microsoft SQL. So there are different types of SQL type databases. The list goes on and on and on. Some of the most popularly used are PostgreSQL, MySQL, and Oracle DB, followed by Microsoft SQL. So these are some very important and major examples of SQL type or relational databases. You would be surprised to know that all the relational databases are queried in a very similar language, which is called as SQL. So all the major relational databases, they are queried, or the access or the way to actually query this database is very similar and is called as SQL. So we write some instructions in SQL and give it to the database so that the database can give us the results that we are expecting for. Let's go ahead and look at a real-time SQL type databases and write a few queries in SQL. So coming back to my screen, I have opened my browser and I am currently opening a website called as mycompiler.io, wherein I have chosen the SQL type as my language for writing code. So you can see that if I zoom into my screen, there are a few instructions that are given. So I can see that I have written create table students. Okay, create table in students, wherein there are three properties separated by commas. So first property is ID, whose type is integer, and then I have written something called as primary key. Now what is primary key? I will get back to it in a second. The second that I've written is called name, and its type is text, and then something like not null is written. Then the third is gender. Again, the type is text, and after that, not null is written. So what is primary key? What is primary key? If we have to talk about primary key, it is a very important concept of any type of database, whether it is relational or non-relational. To give an example of primary key, let me take you back to your university or school days. When you were studying in your university or when you were studying in your school, you must be having something called as an admission number or registration number or roll number. Now, your admission number or registration number would never be the same as any other student in the school. Like, for example, when I was in school, I used to have multiple people in my class who had the same name, including some very common names like Abhishek or Ujjwal or Akash and etc. etc. So it was very uniquely, or it was very difficult for us to identify when somebody said Akash. Then it was very difficult for us to identify which Akash are you talking about, because probably there are 20, 30 Akashas that are studying in our school. So the university or any major organized institutions, they basically take an idea of something called as a registration number or admission number. This number is uniquely used to identify every single student that has ever studied in that school. So this is an indication that there can be some properties associated with your data that can uniquely identify some properties that are related with every single information that is present in your data. Okay, so I feel like I have just seen that there's a question that has popped up. Let me go ahead and have a look at this question. So I see one question on my YouTube live, which is I joined the webinar yesterday and I felt good and visited the website of Tutorac, where I found it as very good platform who wants to start a career in IT field. Well, thank you very much. And the other question is, the DBMS acts as an interface between what two components of enterprise? Okay, this is a question. Let me just read it again. It says that DBMS acts as an interface between what two components of an enterprise class database system? Okay, so what it basically means is that whenever you are using a DBMS, which is standing for database management systems, the question is talking about that does it act like an interface between two components of an enterprise database system? That is the main question. So if I have to put this into perspective, well, it does definitely act, because it does follow that principles that I've just been talking about. So just a few moments ago, I was talking about something called as ACID. In case if you have just joined the session right now, so ACID stands for atomicity, consistency, isolation, and durability. These are some important properties that actually come out of the concepts of DBMS, which is database management systems. And these properties are followed by all the databases. So whatever enterprise level database you have, this DBMS acts like an interface between the database as a software in general and your computer, so that all those principles and all those rules and regulations can be followed to maintain the importance and integrity of your database. All right, so coming back to my screen where I was telling you about some important or some basic live demonstration of how relational type databases or SQL type databases can look like. So yep, on my screen, you can see I have written something called as create table, which is going to create the table for me. And then I'm trying to insert some values over here. So I want you to notice the order of these three things, where ID is called as a primary key, which I just mentioned is going to uniquely identify any single row inside our database. And then there are other properties of students like name and gender. And then I have added three values, like one as the employee ID and Ryan as the name and M as the gender. Then for inside the same table students, I've added another information or another student whose ID is 2 and name is Joanna, and the gender is actually F, which is female. And the third student, which is ID is 1, and then the value is Shantanu of name, and M is the gender. So suppose if I remove this line for now, and if I try to run it, you will see an error coming up on the screen. Okay, the error says line 10 stepping unique constraint failed. This is happening because this is a schema that I've already created for my students table. According to the schema, the ID has to be the primary key. Now, whenever we talk about primary key, it has to be unique in every single way. Now, if you notice over here in my third line, the ID for the student Shantanu is actually same as the student Ryan, because of which it is throwing an error. So in case if I change it to 3, okay, in case if I change it to 3, and if I try to get all the records of my database, I can just run it, and you will be able to see all the 3 properties or all the 3 rows that have been added to my database. So this is how relational type databases are going to work. Now let's talk about the other type of database called as non-relational database. Non-relational database are technically, if you like, I kind of really like them a lot because they're extremely flexible and they're very easy to use with. Just a few moments ago, I was telling you about a spreadsheet-like application where I was trying to demonstrate that how a relational database will look like. But a non-relational database does not have to follow any of these constraints. Technically, all the constraints that I told you about in terms of a relational database, none of those constraints are followed in non-relational database. For example, your schema can change over time. You can have a lot and lots and lots of data at the same time. You don't even necessarily need to have a specific primary key in your database at all times. Like it's not true for all non-relational databases, but it's true for many of those non-relational databases. So there are so many interesting properties that are actually present inside non-relational database. They don't even necessarily need to follow something called as ACID properties because they kind of follow their own BASE properties. So let's try to talk about these BASE properties. So BASE, out of which BA stands for basically available, which means that your NoSQL type database is kind of always available. And S stands for scalability, which means that of course it can be scaled. And E stands for, I think it stands for eventual consistency, which means that it is going to maintain its eventual consistency at all single times, or event-based consistency at all single times. So that is what it means. Now, there are so many major examples that are present for non-relational type databases as well. To name a few, it will be MongoDB, CassandraDB, CosmosDB, etc., etc. Few of my favorites would include MongoDB, DynamoDB, particularly. So there are so many non-relational type databases again. Again, non-relational databases will look similar to relational type databases, but internally they are very different because they don't necessarily need to be that strict and rigid as like a relational database would be. Let me show you a non-relational database in real time. So currently on my screen, you are seeing an actual database, which is MongoDB. MongoDB happens to be a non-relational type database. So right now, you can see that these are the names of my table inside my MongoDB database. So this is all sample data, like sample underscore Airbnb, sample underscore analytics, sample underscore geospatial, and so on and on and on. Let's go to sample restaurants. And let's click on sample restaurants. And let's click on restaurants. Okay, so here we are. So this actually is very similar to one row of data inside a relational type database. So if I compare it with you, this is one row of a relational type database. This is another row of a relational type database. Whereas in a non-relational database, you can see that it looks very much like a JSON, right? It looks very much like a JSON. So in a non-relational database, we always store information in a document structure or in a record structure. We don't necessarily need to store it as rows and columns. Okay, so here all the keys referred to as the type of the property or the type of the nature of that property that we are using, and the value is actually its value. For example, right now you can see that cuisine is American and it's written as a string. I can directly go inside my database and try to edit it in real time. So if I edit it, let's say I change American to, let's say, I change its property from string to, let's say, a number, let's say int 32, and I change the cuisine to, let's say, 3030. And if I update it, you will see that it has now successfully been updated. But on the same side, if I come to my relational type database, instead of writing the primary key as a number, what if I write it as a string? Suppose I write it as a string that's in name. Okay, and if I try to run it now, you will see an error coming up. Says data type mismatch. Okay, so this is one of the major differences between a relational type and a non-relational type databases. That is, we need to make sure that in relational type databases, the schema has to be followed. Whereas in a non-relational database, the schema becomes flexible and it can be changed over time. Let's see if we have any more questions. I see actually quite a few questions popped up on the screen right now. And one of the questions is, which is better, relational or non-relational database? Well, that's a very good question. And that's one of the things that we also wanted to talk about in this particular live video. So when we talk about relational database or non-relational database, it will come down to, the use case of storing the data or how you are supposed to use the data that you're trying to store. If your data is primarily search heavy, for example, let's say you want to create an e-commerce website and you want to store a lot of products on your website and you want people to actually be able to search for each of these products with their name, price, brand, and other things like category, blah blah blah, then in that case you can use a non-relational database. But in case if you want your data to be extremely structured and very rigid and very predictable at the same time, then in that case a relational type database is going to be better. So technically, as a software engineer, whenever we have to decide what database to choose, we try to understand what is the idea of using our database, what is the purpose of the data that we are actually storing. If this data is primarily very search heavy, or we want to create a lot of indexes on it or search on multiple fields, and not necessarily we want to search for one word in general, then in that case we actually try to prefer a non-relational type databases. Non-relational type databases are also very much preferred whenever the data is whenever the data is flexible and whenever we want to perform a lot of analysis out of that data. Whereas relational type databases or SQL type databases are important, and they are usually considered whenever we want to store like important information like records of employees, students, or very non-changing data in general. So storing, let's say, metadata of YouTube videos, or storing the metadata of students and how much marks they scored, etc., etc. So in that kind of situation, we will want to use a relational type databases. So this is the main idea behind choosing a relational type database and a non-relational type database. There's one very important point that I also want to mention, that you might also want to consider the scalability of your databases. So whenever we talk about non-relational type databases, which is NoSQL type, these databases can be horizontally scaled. That means very much like virtual machines, if you just add more and more databases in general, then the data load can be divided into separate databases and your system will become faster. Whereas in a relational type database like SQL or PostgreSQL, you might need to vertically scale up your database. That means you have to add more resources to your same database in order to make sure that it performs better and better. But in most cases, we technically see the size of the data and the purpose of the usage of data in order to decide whether we want to move forward with SQL type databases or NoSQL type databases. Let's see if we have, I think one more question has popped up. But for non-relational databases, we'll always be creating deadlock for resources available, as there would be no concept of permanent primary key. Well, technically, the question you have asked would be true, and the point that you're actually trying to put is correct, as long as there is no primary key. But the non-relational databases will also have their own versions of primary key. If you look into my screen right now, I'm currently using MongoDB, and this ID property is acting as the primary key here, which is going to make sure that I'm uniquely able to identify every single row inside my system. But if we talk about another non-relational database like DynamoDB, which is by Amazon, it contains a different type of primary key concept, which is a combination of something called as partition key and sort key. So it might necessarily not have a relational database like primary key, but there will always exist ways with the help of which we can make sure that our databases can uniquely identify every single record that is present with our systems. All right, so that's pretty much it from my end. There must be a few questions that we were probably not able to answer in today's live video, but that's okay. You can leave your questions in the comments and I will get back to these comments as soon as I can and type my answers as with all the knowledge that I currently have with me. So yep, wrapping up today's session, and I will see you in the next one. Until then, stay connected with us at Tutorac.